So today we're going to talk about whole building testing, and so that usually involves a blower door test where you have more than one fan. And so things get a little more complicated when you do that. I'm sure most of you have either seen or done a blower door test, maybe on a single family dwelling or an apartment where one fan's involved. But when you get two, that's when it's good to have some software involved. And so we'll pull that open and show you how that works as well. So I'm going to go ahead now and share my screen. I've got a few slides I want to go over to talk to you guys about building preparation and some of the planning that goes involved. There's a lot more planning involved with whole building testing than there is with single family, as far as planning where you're going to put your test station, where your laptop's going to be for your software, what doors are you going to use to put in fans, if there's elevator shafts, how you're going to set those elevator cars up, and things such as that. So this is a good manual to have, the Multifan manual. You can just download it off of our website under support and articles. This is what I want to dive into now, is the planning and the site prep, because this is where things get quite a bit different from the single fan testing on houses. So how you set up or how you plan for this can really, what it really determines on is why you're testing. You know, if you're doing passive house, honestly, you know, that's probably going to be new construction, and you know, you're trying to get your builder to meet that certification. So if they're doing passive house, I'm sure you guys are probably working with them from start to finish, from the planning stage on through. So I'm not going to talk too much on that, but if you're going to be just doing the test, that's great. If you're going to be doing the test and then looking for leaks in case it doesn't pass, it's good to have that building to yourself as long as you can, at least, you know, for the day, to be able to work that building and go through and see why it's not passing. So if you're going to use thermal, or if you're going to use smoke generation, that stuff takes time. And usually for buildings of that size, you want to have, you know, at least a crew of a handful of people at least to go through and do certain things. You know, one thing we like to do if we're troubleshooting is, you know, if you just have the handheld smoker that we make, it's a handheld fog machine. And what you can do is you'll have all your interior doors open, but say if it's like a condo or a classroom or something like that, if you inject the smoke into the interior doorway and you're pressurizing the building, if that smoke moves in, chances are there's going to be some leaks along that exterior wall somewhere. Or maybe there was a window left open, or there's a broken window or something like that. Some way, you know, there's air going to be leaking on that exterior wall. So having just the small smoke puffers really help with that, because it just makes that air current visible that you're creating while pressurizing the building. So timing is really important to plan for here. And you really want to have the building to yourself. You don't want workers coming in and opening doors and things like that, stepping on tubing when you're trying to get your readings and then trying to troubleshoot to see, you know, if the test fails, why it did. So you really just want to have your team in there without any interruptions, because when it does happen, you know, it can really throw a wrench into things. Another important thing to really consider here is the prep work. Who's going to do that? Is the builder going to have, you know, some of their people do that, or are they going to rely on you to do the prep work? Because really that's, you know, prep work in itself is about a day's work sometimes. There's a lot more to consider when we're working with buildings like this that require a multi-fan test. There's going to be exhaust that we're going to have to tape off somehow. If there's going to be a commercial kitchen in that building, we're going to have to figure out how we're going to tape off that exhaust there. So those are some things to consider. It's always good to have a copy of the plans. And if you guys are mainly doing passive house, I'm sure you're going to have that. And you really want to take a look at those floor plans to see what's going to be the most ideal fan location. Because when you're doing multi-fan tests, you're going to have cables coming from your gauges to a laptop somehow. So you're going to want to see, okay, where's the most ideal central location for me to have my test station, my laptop set up, if I'm going to have fans set up on one side of the building and another group on the other side and having cables run in, what's going to make the most sense? If it's a taller building, sometimes we recommend having fans, if you have access onto the roof. I'll show you this later. And there's situations where you have to run tubing and cabling, maybe downstairs or down an elevator shaft to make everything reach. So those are some really important things to consider. You don't want to get there on test day and then have to figure that out. So really going through the plans to figure out how you're going to have everything laid out is a really important part of this. And having your test dates and times. There's a lot of people that I know that do these kinds of tests, and they'll do it at night after everybody leaves. And if you're going to do thermal imaging, sometimes you get better shots that way. So it's really up to you how you want to do that. Again, like I mentioned before, you want to have the building to yourself. So again, there's people that'll show up at 3 a.m. and go ahead and get started on this before everybody shows back up to the site. So it just depends on the construction schedule and when they can get you in there, because you really don't want to be rushed when you do this kind of thing. I don't know how big of buildings, with Passive House, you're probably not going to need all that much fan power, but I'll show you this later. We actually have a number of fans calculator. So that way you can put specific aspects about the building, the total surface area, the volume, to show you how many fans you're going to need to meet whatever standard that you're trying to test to. And if you don't have that much, you can rent them. So that way, if you have to go through that process, you can have, make sure you have time to get those fans sent to the job site on time. So we talked about scheduling and time of day. If the building's already occupied, which I'm not sure that you guys are going to be dealing with too much, but we have a lot of customers that troubleshoots problems in existing buildings. So that's when stuff gets really tricky because, again, you want the building to yourself. So, what time of day is going to be ideal. And, a lot of times it's at night. That way when everybody's out and you have it to yourself. I think this is really important for new construction. 2 weeks out, you want to go walk that site with the GC, the HVAC guy, the building engineer, if there is one there, to make sure that everything's going to be set up the way you need to, that you can get all the HVAC shut off. If there's building automation software built in, have the building engineer there to have everything shut down. If there's large exhaust fans on timers and things like that, to make sure that those are going to be shut off. I've definitely run into situations before where we were trying to test a building and there were several large exhaust fans running, pulling that building 30 pascals negative. And this isn't something that they considered before we got there. So we had to spend half a day running around trying to figure out how to shut those fans off. So if you can go ahead and troubleshoot and get that stuff set up before you get there, all the better. The less that can go wrong with these tests, the better, because there's just so many moving parts. But definitely don't let that deter you from doing this. As long as you plan accordingly, you're usually good to go, and just have everybody involved and in the same communication network there. So whoever's in charge of getting that building set up for you, just make sure that they're doing their job on time too, so that you can get in there and knock that test out and be done with it. And that's where this kind of goes back to see, okay, who's going to be in charge of this prep work? If you're in charge, then again, you've got to make sure that you can get in there and get things done, get fans shut off and things like that. And 2 days before, we put this into, this isn't like a strict thing where you have to do this 2 days before, but, whether it's 3 days or the day before, it's always good just to walk through and make sure nothing changed, that everything's going to run smoothly whenever you do run your test. Maybe go ahead and get some of your equipment in there and ready to be installed. In some cases, maybe you can go ahead and put up door panels and things like that. So that way you have less to do on test day. And if the GC has dedicated people to help you out, go ahead and make sure that they're going to be there and they understand what their job is to get you rolling. And this is a good time too, just to make sure that your test equipment plan is actually going to work out. And this is a good job to do this too when you do your walkthrough before this. Sometimes things on paper don't quite work out like they do when you actually walk the site. So you just want to make sure that test setup plan that you made when you looked at the building plans is actually going to work in reality. So you can actually go and see those doors with your eyes that you're going to set up the fans into, look at the area where you're going to set your laptop. Because there's, if it's multi-floors, you're going to want to run reference tubes up to make sure that the whole building is going to get to your desired test pressure. For these types of buildings, you're going to usually be doing a multi-point test. So if 50 pascals is your number you're shooting for, then you're going to want to go up at least to 60. If it's 75 pascals, which is what most commercial buildings are tested to, you usually start at 80 and then work your way down. This is where you can kind of see those pathways and how that's going to work to get those tubing assemblies laid out, how doors are going to get propped open and things like that. Make sure you have enough equipment, enough tubing, the right cables and everything to hook up. And again, on the plans too, it's important to look at that sectional drawing to see, okay, well, what is the actual air barrier of this building? We've tested buildings before where there's an entire top floor that includes elevator, penthouse, some mechanicals and things like that. And there was a, kind of an argument between, the testing firm and the building engineers, like, is this inside or outside? And so you really want to have all that stuff confirmed because when you get into these types of commercial buildings, you'll have rooms like that. Elevator penthouses, large mechanical rooms that are kind of right on the edge or at the top of the building. And so you want to determine, are those part of the air barrier or not? Are we sealing that? Are we leaving it open? So go ahead and have that planned out. That way when you are setting up for the building and getting ready for the test, you know what to do with those parts of the building. And this is a good diagram that I like to kind of show the general outline of how some of these buildings work. Usually you'll have a stairway column going up here, and there'll be doorways going to these stairs that you'll have to have propped open. Sometimes you'll be running tubing through these stair pathways to gain access to make sure that all parts of the building are meeting the desired pressure that you're testing to. And same with the elevator shafts here. Do you have to set a elevator car halfway in and halfway out? Is there a way that you can move it to drop cords and tubing down to get down to your test center faster? So these are all things to consider before you get there on test day. And I talked earlier, how many fans do you need? We have that number of fans calculator. If you just go to our website, you can download it. It's an Excel sheet. And I think everything you input is blue. Everything you input is green, and then the results are blue. But it has different test standards on there. If you're testing to a different program that has its own set of standards, you can customize it. You can let it know what type of fans you'll be using. So with Retrotec, we have our 5,000 and 6,000 model fans. So this is the 5,000 here on the bottom, 6,000 on the top. They look identical, but one is a standard power. This is a high-powered fan. So this one, without any back pressure, will max out a little over 6,000 CFM. This one will do a little over 8,000 CFM. So depending on what fans you're using, if you're using all high-powered fans, and you're not going to need as many as you would if you're just using the standard power. Yeah, and that's just more information on that. Let's see here. And so this is another reason why you're going to need those plans, because as you enter that information into the number of fans calculator, it's going to ask you for this stuff. What's the total surface area of the building? So you're going to need to be able to add all that up and enter it in, so that way the software can help you out. And another thing to mention about the number of fans calculator is it's just the raw math. There's no cushion built in. So if it's saying that I need 4 fans to do this test, I'm probably going to get 5 or 6. It's always better to have too many than too little, because if the building is leakier than you anticipate, you at least still have the fan power to get a real blower door number there with good accuracy. And you guys can play around with that. I'm not going to spend too much time on how to add up what your surface area is. I'm sure you guys have done that before, but this is just a closer look on what that calculator looks like. Like I mentioned, it's an Excel sheet that we built just to kind of help you figure out how to see what equipment that you're going to need, or if it's equipment you already have, if you need more, that way you don't come up short. So here's a little more on building preparation. If it's new construction and you're there, maybe there's a window that wasn't installed or something like that, maybe that guy was behind. That's really the only window that you can get in and test. Sometimes it's good just to go ahead and patch that up with plastic and tape and just keep rolling with it, and not let that, completely slow you down if it's just one little thing you're waiting on. You can see this exhaust vent here that these guys are taping up. These are pretty common that you're going to see on some commercial buildings that you'll do multi-fan tests with. So you'll want to make sure that you can get those taped off. Having big rolls of plastic and tape or something that we usually use in the field Sometimes you can use duct mask tape, and if it's a large commercial kitchen hood, you can usually tape those up from the inside too, if that's going to be easier. So that's where just walking that building and coming up with a plan to do that with really is valuable. And that way you can kind of make your notes and determine who's going to do what part. So yeah, so getting all of those ventilation things taped up there. And like residential buildings, you're going to want to have the whole building open. So all your interior doors. And like I mentioned earlier, there's a lot more to think about here. So to get the whole building connected, that's where we open up elevator doors. That way, we can get air down the elevator shaft. All of our stairwells we want to have propped open, and that gives us a pathway to run our tubing too. Let's see here. We'll talk some about equipment, and I'll kind of give you a close-up too, just to show you how we connect everything. But let me run through this right quick, because if you do end up renting fans from us, we do have some of our older fans in our rental fleet. So depending on what you ask for or what you get, setting some of these fans up can differ a little bit. So the 3000 is the precursor to this 6000 model. So they both output the same amount of air. So a little over 8,000 CFM. And our 1000 and 5000s also have the same output. We just changed the range configuration and made the shell lighter and more durable. Our frames, there's the frame and canvas option that I'm sure a lot of you are familiar with. And we have an extra large size too. So for commercial buildings, you'll be dealing with some larger doorways. You have that extra large option to fill that. And then of course, for Multifan, we have our 2-hole cloth, our 3-hole cloth. I'm sure some of you have probably seen some pictures of large tests where you have 3 fans stacked in a doorway. So usually in an 8-foot doorway, you'll have room to do that. But there's other options as well. We have our modulating hard panel that can go into a doorway. This basically just comes in 3 pieces, and it expands in both directions and can plug into a doorway like that. We also have, this is called a QMG panel. This is used for our older fan style. I'll show you a little bit more on this on the test we did last year. But one thing that's kind of taken over that is, you probably see here, is the stacking panel. I'll give you a close-up on that. And basically what this is, it's a square frame that your fan can just snap onto, and then you can make your own hard panel out of whatever you want, whether if you just stick build a 2x4 or 2x6 frame for it, or you can do what I did here, is just get a thick sheet of plywood, and you can just cut out the square holes, screw it in, pop your fans in, and you're ready to go. So for some large test applications, like you see here, I doubt you guys are going to be dealing with something like this, but there's several options in how you can install that fan in the doorway. So the way you hook your fans up to your software, to your gauges and to your software, is really important. And this is what we call common control. And I'll give you a close-up here on this in a minute. But what this means, this is called a master-slave relationship. And so this gauge here on top is going to be the dominant gauge. And this is really the gauge that's telling the rest of the gauges or the rest of the fans what to do. And this is unique to Retrotec fans. So this is where the 2 brands really differ. So with Retrotec, we like our fans to be spinning at the same rate at the same time. If you use energy conservatory stuff, they have what's called, it's more of an individual control. So each fan is connected to each gauge. But the issue with that is you have to, you can get your first fan spinning, but then you have to leave this fan covered and get it up to pressure and then pull the cover off of it. Otherwise, you can get the fans fighting each other, which is definitely what you don't want. So with our fans, what we have is, so with individual control, you can get fans spinning at different rates. And, if you use that equipment, one thing we recommend to do is look at the motors with a thermal camera. If you have, a few fans that are one temperature and then you have another fan motor that's really hot, that one's likely spinning at a different speed and maybe getting pulled into a different direction. So that's why we overcame that and did our common control method. And I'll grab you guys in a minute and show you what that looks like on the fan shell itself. So there's a couple of different ways you can, a few different ways that you can connect your gauges to your laptop. So our testing software is called FanTestic. And that's the software that you can use to really run whatever size test you want. I did one last year with an engineering firm where we had 33 fans running a building. And we ran it all up on one computer. And so when you get into a situation like that with a large building, what you can do on our gauge, you have a Cat5 port and a USB port on the bottom. And so you can run your Cat5 cables off the bottom of the gauge into a router or a Cat5 switch box like you see here, and then into your, having one line go into your PC. We also have the micro USB option, which is the way I have mine hooked up today. So you can just use a USB hub to hook them in that way, and their Wi-Fi. So if they're all within range, then you can connect all those gauges to your computer that way. Yeah, and so with the individual control, we've seen it in some cases where one fan might get pulled into the backwards direction by another. So having the common control where everything is tied in and running at the same rate at the same time, you're never going to have that problem. And you can always just have them open and start off at the same time, and it'll never be an issue. And your power source is important too, especially if you're going to be using our high-powered fan. These take up a lot of juice, so you want to have one circuit per fan. For some cases, if you have a group of high-powered fans, what some companies do, and they'll add this into their budget before they send a bid over, is to have an electrician just come in and build them a panel box right there at the test center. That way you have power right there for each fan in one spot. And I'll show you later what some of those test setups look like. Otherwise, you risk blowing a breaker or tripping a breaker whenever you crank up some of these fans to go. So that's one thing we always recommend, circuit per fan. And so I mentioned earlier that you want to get reference tubes to each floor to make sure that the entire part of the building is going to be under that desired pressure that you're testing to. So if you're testing to 50 pascals, you want to make sure you have tubing up there to reference the top if your fans are at the bottom, to make sure that that building is getting a universal pressure all the way through it. And so what that would look like here is, this is our cabling that I talked about before. You'll have one group tied in if you're using the Ethernet or USB route to tie into your laptop. Similar to, single fan blower doors, we have everything color coded on our tubes, on our gauges. So red is going through the red panel to the outside. So that's going to reference outside. And it's good if you have a group together just to go ahead and tee them together and get that reference tube outside. And then coming off the blue, which, for a blower door test, usually for a single fan test, you usually don't do anything with this port just because it's reading your building pressure right there at the gauge. And for houses, that's okay. Usually, as long as you have all of your interior doors open, you're going to get that universal pressure throughout. But for buildings like this, we want to be able to take tubes and reference each floor to make sure that we are getting that desired pressure all the way throughout. So within your planning process, this is what I was talking about when running tubing. You want to be able to make sure you have a good pathway to do that. So that kind of covers the basic setup. And I'm going to stop sharing here. And then I'm just going to pull you guys over here so you can see what I'm talking about over here in real time. So one difference, I'm going to point you guys down. And I'll pick this up for you. On our 6000 model fan, it actually has a separate variable speed drive. So this is one of the things that makes it a lot more powerful than our standard 5000 model. And if you notice, there's two Cat5 ports on here. So one for in and one for out. And so this is how we daisy chain those fans together. So if this is my master gauge here at the top, it's got the Cat5 port going in to the fan. Then I have another cable coming in to my 5000 fan here. So this is getting a signal from the previous fan. So this fan is going to do exactly what the one before it is going to do. That way, they're spinning at the same rate at the same time. And if you notice, this other gauge is just kind of along for the ride. It's just collecting data from this fan. So there's no Cat5 plugged into it here. It's like I said, I'm using USB. So this USB cable is just going into a USB splitter that I have to feed into my laptop. So you've got some options on how you want to connect. You can use the Cat5 port on the bottom here, or you can feed into it through USB. The one reason why some people use Cat5 over USB is because you can get longer cables. So some scenarios, you might need 300 feet of cable to get from your fan group back to your laptop. You really can't get a USB cable that long. You'll have to have several repeaters in it, and the signal will get weak over time. So that's why we give you different options, just depending on what kind of scenarios you get into. But yeah, on our equipment, we try to make it as simple as possible. There's, again, there's 2 ports on each fan, in and out. So that way, if you've ever seen that out port on our fans before, that's why it's there. So you can just plug another fan into it and keep the line going. So I think that's a good spot to stop for questions, Aaron, if we have any in the box.
Yeah, we do, Sam. Do you have any guidelines on how to set tubing around the building to check pressure throughout the building?
So are we talking about, when you say around the building, like is that for outdoor reference? Or, yeah, because if we're talking about our reference tubing within the building, if we go back to that slide that I had before, here we go. So this is really what I was going over on this slide here. And so it can vary per building. This is where that site walkthrough, a couple of weeks ahead of the test or a month ahead of the test is really going to be helpful to you. So that way you can see what pathways you have to run this tubing throughout the building. This could be a stairwell. This could be an elevator shaft. Each building is going to be different. So you really just need to walk through and see what your options are to run those buildings up or to run that tubing up. Oh, and I have a quick video that goes through this too. Let's take some more questions and I'll
Yeah, and there's a related question on the reference tubing. How do you deal with it for taller buildings, say 15 stories or higher? Are you running this to each floor? Or are you going from the top to the bottom?
Yeah, so in some cases, you can split that reference tubing and then go to reference one gauge to several floors. And if you're getting a good even pressure throughout, then you're good. For taller buildings like that, I mentioned before that, we may not have 2 fan groups on the bottom. We might have, maybe another one here on the top somewhere. And so that way we can actually drop down some reference tubes and come in from the top also. And then so all those reference pressures are going to be fed in to our one test station. And so in the software, we'll be able to see once we go ahead and do a test run with our fans, if we're getting a good unified pressure throughout. So yeah, you want to be able to measure as many floors as possible. And if you're getting into like a 15-story building, you may go every 2. As long as you're getting a good sample throughout, then yeah, you're going to be able to see that in the software.
Great. And the last question here was actually, kind of around safety. Do you get any pushback from GCs on safety concerns? The question was about open elevator doors. Yeah. But broader does it, for any of these setting up of the testing?
Yeah, that's a good question. And that kind of goes back to, who's going to be responsible for setting that up. So the building we tested last year, it was 13 stories and it had elevator shafts. And so OSHA recommends having basically you build a wooden fence that comes out and around so that you can't stumble into it. Those are going to have to be built before the tests to be able to meet those requirements there. So usually that's going to be on the GC or the building engineer, whoever's going to be in charge of getting that building prepped for you guys to come and test. So yeah, that's a good question. And sometimes, the GC will just want to have a guy there to operate the elevator. I've seen that before too, where, that's really just that one guy's job is to take us up the floors when we need to go adjust stuff. That usually will fall back on the building operator to have all that set up.
Great. That about covers the questions we have at this point.
Cool. Let me grab this video right quick. I doubt you guys are going to be dealing with stuff like this. This is about as crazy as blower door testing gets. But it was just a really good example to really show how some of this stuff can set up in the most extreme of scenarios. So we had 4 different test stations. And Aaron, can you see this okay? This test setup?
Yeah, this is coming through.
Yeah, perfect. So we had 4 we had 4 fan groups, 1 test station. So we had 18 fans set up in this loading bay area here, and then we had 9 in the main entrance, and then we had 2 groups of 3 on the roof. So that gave us a good, pretty good coverage to get that building under our desired pressure. And so we did this test to the Army Corps of Engineers standard, where you test it. You do a multi-point test at 75 pascals. So that's when you go up to 80 and go down, and we started at 80 pascals and worked our way down, back down to 10.
So this was the largest test station that we had set up. You can see here there's 18 fans, drives, and gauges that we have. And we had to stick build this wall assembly here in the garage bay door area. That way we could lock these fans into place. Some of our older fans have a green port where they collect that building pressure at the fan. So that's why you'll see this green tube going to some of those fans. Our newer fans don't have that. They'll just collect that pressure reading right there at the gauge. But this blue port is what you see. It's going to be collecting pressure throughout the building.
And so this was before this company knew about our stacking panels that I have here in my setup. But we were able to make it work by going and getting some plywood, getting a router, cut out holes for the fans, and then we just kind of sandwiched the lip of the fan shell in with a piece of 1x, and it worked fine. So you're usually pretty flexible as far as how you want to set your fans up. And this is what I was talking about before about getting your power in. They just hired an electrician to come in and run this to them, so that way each fan could be on a separate circuit in the same spot. One thing that I didn't mention before, it's usually inevitable that you're going to have to use a drop cord of some kind. As you add an extension cord, you have a voltage drop. So you probably won't get, you won't get as much power to that fan as you would without it. So that's another thing to consider. You still had to use some to get there, but if you just keep adding on drop cord, you're going to keep getting voltage drops and getting less power to the fan. So that's one reason why they just had this right in here at this test center.
Now with all the gauges laid out, we have each one plugged into a charger. So this was a pretty long test, so we wanted to make sure we had power going to each gauge so they didn't run out of juice while we were trying to collect data. And you can see the drives and everything laid out here for each fan. Now you can notice the Cat 5 cables coming out of the bottom of the gauge. Each gauge has one coming out, and then there's a big Cat 5 switch box here. I could not get a better picture of it. Well, I could have, but I just didn't. Wasn't thinking about it at the time. But all these gauges are feeding into the switch box, and then there's one cable coming out of it that's going to our laptop at our test center. And as each gauge is connected to the switch box, each one of these drives is connected to the next one. So that's that daisy chain configuration that I discussed earlier. That way, each of these fans will be running at the same rate at the same time. So there's going to be another Cat 5 cable going into one of these variable speed drives, and then another one going out and running to the next one. That way you don't have to start off each fan one by one. You can just crank them all up at once. Now here we have the fans installed with the shower cap covers on. Notice how those covers are ballooning inward. That's from that stack effect from the building. Well, it's a mixture of the stack effect and some of those exhaust fans that we had to hunt down to figure out how to turn off. But here we're doing some last minute treatment here to our wall assembly, finishing out, cutting out some of those holes so the fans would be able to pop in. And this is an example of what I was talking about before. These cables and tubing are coming from our two fan groups on the roof deck. So this is on the top floor, and this cable and tubing are running down this stairwell. This reference tube is running back to our main test center along with the cables from each fan group.
Unfortunately, there wasn't really good communication between the testing team and the building operators or the building engineers. So there wasn't as much prep work done as there needed to be. So there were these big louvers in the elevator penthouse up here that we had to go up and seal off. So you can see this roll of plastic up here, and then we had to screw in some 2x4s to keep it sealed off. Otherwise, we wouldn't have been able to get the pressure, the building under pressure. And so there were several of these, what we call them like mushroom caps, exhaust fans here up on the top on the roof that we had to get taped off. So a lot of plastic, a lot of tape to get these things sealed. But once everything was sealed off and we were ready, right when you hit test on the software, it'll go ahead and kick on all of those fans at the same time. So since they're all daisy chained into each other, you don't have to worry about them fighting each other. So they all kick on at the same time. And this next running up, it's kind of sounded like a NASCAR race in there. But mainly, there's really no building too big. As long as you have, the time and the manpower, you can get in there and test. You just have to come up with a good plan to how you're going to run your equipment down, or your tubing and your cables from your equipment to your laptop. And so with the building of this size, as leaky as it was, we were able to come in and get some good data out of it to feed back to the engineering team that hired this company. And we were able to verify that, yes, air leakage was a huge part of this, and to come up with a plan to get it still tighter. But so one thing that you really want to do before you go ahead and start collecting data is go ahead and ramp all the fans up to the highest pressure that you're going to need to get to. So like I mentioned before, we were doing 75 pascals here. So we wanted to just go ahead and ramp the whole building up to, or down to negative 85, just to make sure that we were going to get to that highest pressure, to make sure we had enough fan power. And then once we were able to verify that, then we were comfortable with going ahead and running the test. And this is that QMG panel that I was telling you guys about earlier that comes with our that works with our older fans. And what they did was, and there's a better shot of it at the end, but they just built a 2x6 frame for it and just plugged it right into that door there, and it worked great. And it's 3 panels on a hinge, and they just unfold. And then it's really up to you how you want to get it in. Some people, they might just tape around it or take a couple of 2x4s and put it in that way. But building that wood frame around it, what these guys did, worked out nicely. And these are just some other shots that I got while I was there. Let's see. Oh, yeah, there was a hawk up there eating lunch. Thought it was a good idea to put that in, but maybe it wasn't. But, you'll see some more stuff sometimes. So this is that handheld fog machine that I was telling you guys about. And we actually have a new one coming out that's half the price and more capable next month. But I think this was even without the fans running. There was so much stack effect in this building from the leakage that we could just identify it with smoke. And this was those louvers in the elevator canals. And there was really no rubber gaskets on any of those, and they were all seized open. So it was just driving that stack effect even harder than it should have been. And yeah, just having the smoke and walking around to see air currents really helps. And we were able to capture some good thermal images here too, where we're depressurizing the building, and then looking up, you can see the metal corrugated roof deck there. And there was some fiberglass insulation stuffed in. Maybe that was acceptable back in the 80s, but obviously it doesn't work very well. And so we can see that cold air coming in from there too. So with the major stuff, like the louvers and the elevators and the roof deck, it's kind of death by 1,000 paper cuts in this building. There was really no air barrier on it at all, so it just leaked like a sieve. Here you can see our drives and our gauges here lined up. Everything teed together, working together, running at the same rate at the same time. All of our test panels are taped to the doorway. But here you can see the QMG panel from the outside. And with our older fan model, you can kind of pop it in there and twist it and lock it into place. And here you can see the wood frame they built around it and sealed it up to the doorway, and then just run their cables in through another door. So that's just kind of a quick example of a test that we did in a pretty extreme scenario. So any questions on that came in from that?
We don't have any new questions here, though. If folks have any, please type them into the chat.
Okay.
And let us know.
Cool. So let's run some fans. I'm going to go ahead and get some software pulled up here. So this is FanTestic. We actually have a new version of this that's going to be coming out sometime next year. So I'm just going to kind of run through and just show you how things set up and how it communicates with your test equipment. So first off, what we want to do on our gauges is to make sure that they're all set on the wired settings. So if I go into my settings, if I go all the way to the end, I can see network. And this one's on Wi-Fi Create. I'm not running wireless, so I'm going to keep going through until it says wired. So that way it knows to send a signal through, whether if it's plugged into USB or Cat5 to the laptop that way. So once I have, the software open and I have my equipment set up, like we just talked about before, I can just go ahead and click on and tell it to find gauges. Are you sure? Yes. And it's going to search for my connected gauges. And a cool thing about this too is it can pull in the stats from all of your equipment that you're using. So if you have your serial numbers for your gauges and your fans, every single piece of equipment that gets calibrated at Retrotec has its own calibration log. So that way it knows how that fan or how that gauge is calibrated, and then it can, when it runs its test from there, it'll factor that in to give you an even more accurate output. And so one thing I need to mention too is these plates that pull off, like the B8 plate here. If I pop out one of these plugs, the serial number for that fan is on there. And if I look here, it's also on this plate. And the reason we do that is because you wouldn't think it would, but each fan is calibrated with its own plate and plugs that comes out of the factory. So it's down to that granular of a calibration process. And so that output is then fed in to the FanTestic software. So that way, whenever you take your plates and plugs off, make sure they all go back onto the same fan. That's kind of what I'm getting at, because it does matter. So there's some things you can do. You can put your technician name in here. If you want to come up with your own coding system for the test that you do at your company, you can give each test a reference number. like I mentioned for my fans, I can tell it to, I can put in that information. I can get my last certificate from Retrotec. I can get my values from Retrotec. I can see, what the flow exponents were when this fan was calibrated. So if I have a code official or somebody that wants to see that stuff when I'm on site with my equipment, I can go ahead and pull that up. So, you can put in the test address. You can upload a photo of the building. If you're sending that report and you want it on there, I just uploaded a photo of the test center. That's what we're doing here. You'll need to input a couple of things in here, such as your elevation above sea level, the height of the building, the volume, the floor area, things like that. So I'm just simulating this as a 10,000 square foot building, and I have the test center to set up to be pretty leaky. I've got all the attic panels down and the attic vents open. I've got the window pushed open, so that way it'll give me some realistic commercial building outputs here. So once you get all of that basic stuff input, you can hide these windows to get them out of the way. Once you get that basic stuff in there, and this takes us to the actual test. And there's really two ways that the software allows us to do it. We have the auto test. So if you guys have ever used our rCloud app while you're doing a single family test, it pretty much does just that. It's just going to go ahead and run an automatic multi-point test to whatever standard I tell it to. So right now I'm doing, this tells you at the top. Yeah, the E779. So if I'm doing a test to try to meet Passive House or for ResNet or whatever, all of those standards are based off of the E779 test standard. So I would run it off of that. Let me move that. But usually what I like to do is what's called the semi-auto test. And that just allows you to customize the test parameters a little more. So if I wanted to start up at 60 and go down in increments of 10, I can tell it to do that. Auto test is going to go up to like 65 and go down like 8.5 each time. It'll take 12 baseline readings. But another thing about the semi-auto is I can stop and start the test whenever I want without screwing anything up. I can pull this gauge view over to the side, and I want to go ahead and tell you guys about this now, because when I get these fans ramped up, it might get a little loud and might be hard to hear me. So one thing I want you to pay attention to is the fan speed, and notice the different colors. Obviously red, it's not running. Yellow, it's not going to pull great data. It's not going to have enough fan pressure inside the fan shell to generate a good, accurate flow calculation. But if it's in this green, it's going to be okay. And so that way, if I'm running a multi-point test and I'm staying in the green from 60 and then drop it down to 50, the speed's going to drop as I drop pressure. But then say if I get down to like 20 pascals and it's here, I'm going to want to go ahead and stop that test, change the range, which I can just do here in the software, mimic it on the fans themselves, and then resume, and then that fan speed will ramp back up. Sometimes if you run an auto, just straight auto, it'll try to get down kind of low, and then sometimes that data won't be as good, and it'll show up as a red number. If I do it in semi-auto, I can just avoid that altogether. So it just gives you more control. Basically, most people who run these tests in the field choose the semi-automatic tests just so you can customize however you want to do it. So I'm going to tell it to begin the semi-auto test. It's searching for the connected gauges, and it'll pull up this box here. And so I still have my fans covered up. So if you just have these hard plates and plugs in, that's going to be okay to do your baseline. You can also use the shower cap cover that comes with it as well. But in order to take my baseline, it's going to say data to collect here at the bottom. And so I want to make sure I select that. And then for fan speed, it's going to want me to enter 0 because it wants to be able to communicate with the fan somehow. And it's going to take the baseline for 10 seconds. but I can change that if I want. But, if it's a super windy day outside, I might want to change that to maybe 20 or 30. But the thing about this is I can take as many baseline readings as I want, and it's going to record them up here. So if I want to take 12 baselines, I can. And then I can take my final bias pressure readings here at the bottom if I want to do that too. That's a common protocol in commercial to take a final baseline. I know the new ResNet 380 standard doesn't require it. So that way, if you're going to do the full automatic test, it's going to automatically take those. If you don't really care, or if 380 doesn't require it, if you're trying to save time, then you can skip that section if you do semi-auto. So I've got my 0% in here. I'm connected to all the gauges. I want to do an initial baseline. So I'm just going to tell it to run fans to that target. And if I move over here, and I tell it to collect that data point, it's going to start to collect. Okay. And now I can see it reading. It's counting up to that 10-second reading. And there it is. It says data point completed. And I see it right there. So now I can go ahead and tell it, and I can do this as many times as I want. If I want to capture, more baselines, I can just keep doing that. But for the sake of time today, I'm just going to go ahead and start capturing my building data. So I'm going to go here. I don't care about fan speed. I'm going to do pressure target. I'm going to start up at 60 pascals. And uncover my fans now. So go ahead and pull these off. I was already playing around with this in last night, so I already know what ranges I need to start at. Chances are, if you're doing a large building where you need multiple fans, you'll likely pull these A-rings off as well. But I know, for the specific setup, I've tested it before, so I know what ranges I need. But you're usually always likely to start these up wide open if you have to use multiple fans to get to that highest pressure target. So cool. So I've got that lined up. Let's see. I need to make sure that I have it on ring A. I do have it on ring A. If I didn't, I could close out this box and then change my range here if I wanted to. And we'll get to that in a second. So now I'll tell it to run fans with the new target. So it usually takes a 20-second reading. And if you notice, the outline of this box is yellow. And whenever the reading is good and it has good data, it turns green and it says the target has been attained. So now that the fans have balanced out, I can go ahead and tell it to collect that data point. Hit OK. Now it's collecting the data at that pressure. And it's going to do that for 20 seconds. And I can see the pressure readings here. I can also see it in the gauge view over here. My fan speed's nice and high, not too high. It's reaching that pressure. It's staying stable. It says that data point's completed, and it's recorded here in this column. So now I can go down to my next pressure target. I'll tell it to go down to 50, and I'll run fans at new target. Now I see that pressure start to drop. My fan speed's starting to drop. It's waiting for itself to balance out at 50. Once it's good and stable, it'll let me know that I'm okay to start collecting. There we go. It says target of 50 has been attained. That's great. Now I can start collecting the data. Okay. Now it's going to run it for 20 seconds. And it'll let me know when that's recorded. There we go. It says data point completed. Great. Now I can drop it down to 40. And tell the fans to run at that speed. See my speed drop. See my building pressure drop. I see here it's waiting for it to balance out. We're yellow, so it's waiting for it to get stabilized. And now it's stabilized. So I'll go ahead and tell it to collect that data point. Okay. And I see it starting to record. And it says the data point's completed. I'm going to go down one more. My fan speed is still pretty good here. If I go down from 40 to 30, I'm going to drop a little bit. So I still see that I have some room. I don't need to change ranges just yet. So I'm going to go down to 30 and tell it to run fans at that new target. And I see it drop. Speed's dropping. Building pressure's dropping. Still waiting for it to get a good stable building pressure. There we go. Now it's at a good stable 30 pascals. Now it can collect the data. And we're almost to the 20-second reading. There we go. It's completed. And it looks like I have room to do a test here at 20 just by looking at my fan speed window here. So I'm going to go ahead and tell it to drop on down to 20. We're still in the green, so I'm thinking I should be okay here. It's just waiting for it to stabilize. Oh, nope. It didn't like how low that pressure was, so now I'm going to pause the test and change the range. So it automatically pops this window down, and I'm going to go to B8. So I'm going to put the plates on, but I'll have all the holes open. I'm going to do that for both fans. And if you remember what I said before about the plates, we want to make sure that we match them up back to where they were. So I can see the serial number here on this fan. I look at the last two numbers. It ends in 78. This plate ends in 71. So this one goes on top. And so when I take these plugs out, I just want to make sure that I keep them all together and that I don't mix them up. That way I don't have to waste a bunch of time later trying to figure out which plugs go to which fan. Because like I mentioned before, it does matter to keep that really good, keep those really good readings as they did when they came out of the calibration chamber at the factory. So that one goes to the 6,000. This next one will go to the 5,000 fan. This is one of the benefits of using the cloth over the hard panels is that our cloth has a row of pockets on there, so you can actually stick the plugs in the pockets. But if you're not using the cloth, then you just have to kind of keep them organized yourself someplace else. So now I've got my B8 range set. You can see that whenever I set, well, I don't know if you can see or not, but I set it to B8 in the software. It automatically switched it up in the gauges too. So I am going to tell it to go back to that 20 pascal pressure with the new range. There we go. Now we see my speeds coming back up now that I've reduced the hole size on the inlet side of the fans. We're getting up close to 20, so this will be a good range for that pressure. And it has attained 20 pascals, so now I can tell it to go ahead and collect data there. And notice how it started two new rows for me here. So I had my data collected under that ring A, and now my data collected under B8. So every aspect of the test will be in the report, from when you change ranges, pretty much everything that happened. So that point's completed. Now I'm going to drop it to 10, and this will be my last reading. Now we're going to drop more. It may ask us to change the range. I don't think it will, though. It might have enough juice in it. Yep, it's going to ask us to change, so we'll pause it and go ahead and plug these back in. So our next one is going to be the B4 range, so I'll go ahead and change that in the software where I'm leaving 4 holes open, plugging up the tops and the bottom. Making sure I'm getting the right plugs from the right stack here. That way all my serial numbers match up. Okay, I'll tell it to continue at 10. It created me a new row here for B4. Now we're ramping our speed back up. Fan speed's getting pretty high on this one, but it'll be able to get there on 10. There we go. It's a target of 10 has been attained. I'll go ahead and collect that data point. And it's been completed. And recorded. So I'll go ahead and stop fans. I'll tell it to let's see here. Let's close this window out. I'll tell it to calculate the data that's been collected. And here's my readings. So airflow at 50 pascals with this multi-point test was about 5,300 CFM 50. And any other reading that you need to out of this per floor area, per envelope area. So 0.11 at 75, if I need to report it in 75, pretty much everything is there that I would need to report. And then you'd be able to export or send that report, email it to yourself, export it as a PDF, whatever you would want to do. So So any questions? Any more questions on anything we've covered so far today?
Folks have questions, you can go ahead and type them in here, or I suppose at this point you can unmute and ask a few. We did have one in here actually about Retrotec trainings. Somebody noticed that you had a 2-day training for whole building blower door testing previously. I was just wondering if this is something that might be offered virtually in the future.
Yeah, if you're interested, just reach out to me. We can put something together like this that's in a lot more detail, where we can get myself and Lee out of our tech support department working on stuff together. We can do all kinds of scenarios. We can also add in multifamily testing, so to show you how to use the FanTestic software to run guarded blower door tests on multifamily dwellings. So that way you'll have several blower doors set up in several apartments or condos or whatever you're testing, and you can run them all together and collect data only from one test group. So yeah, we can dive into all of that and use the same test center here, and that's something we'd be happy to put together if you'd like. So again, my email is just sam@retrotec.com. If you're interested in something like that, just drop me a line and let me know. But yeah, we don't have a lot going on as far as plans for live trainings. Unfortunately, it's just still a lot of uncertainty about when travel is going to come back up. So hopefully, maybe middle of next year, we can start offering some live in-person trainings again. But until then, we're probably going to be doing a lot of the stuff virtually.
Great. Glad you were able to set this one up. I don't see any new questions, but folks, if you do have them, feel free to ask them here. Sam, I have one for you here. I know you mentioned briefly at the beginning how you do smoke tests sometimes. Is there anything different about this setup that you would do if you were going to do a smoke test?
Yeah. So when I do a smoke test, I always like to set it up to pressurize the building, especially if I'm within the building envelope itself. That way I want to make sure I have all other mechanicals turned off, exhaust fans, HVAC system. That way the only air that's moving is the pressure that I'm generating from my blower doors. And so there's a couple of things you can do. Like I mentioned before, as long as you're pressurizing the building, you can emit smoke. I think I have this thing right here, into a doorway, interior doorway. And if it pushes through, then you know that you have a leak going on somewhere in that building. So I'm going to go ahead. I'm going to set pressure here to 25. So you can see it's blowing back at my face. That's why I like, sometimes if it's blowing back in your face like that, it's kind of hard to see exactly where the source of that leak is. That's why I like to pressurize, because if I'm in the building, I see it disappear into the wall cavity somewhere. And it's easier to film, record, take a picture, or just see if it's kind of hard to see what that source is. So if it's the opposite, if I'm in a room that's outside of the building envelope, then that's when I like to flip the fans around and depressurize and watch that smoke get sucked in. It's just easier to see that way. But yeah, the new one that we're going to come out with, it's on our website. It's going to be called the Reveal, and it's a smoke gun, and it'll actually have Bluetooth connectivity. So you can set it up, you can attach it to an extension pole and get up to high, hard to reach places with it, or you can set it inside of a duct system and set it off remotely that way. Or if you're doing some kind of mock-up testing, you can set it inside a test chamber and set it off remotely that way too. So we're hoping middle of next month that'll be coming out.
Great. And we had a new question here. If you can talk about how the setup applies to integrity testing for server rooms. Yeah.
So integrity testing is a little bit different. We have very similar software. It's just called FanTestic Integrity. And so you have to know what type of fire suppression, clean agent fire suppression that you're using, whether if it's inert gas or something else. because those types of gases behave differently and have different retention times. So usually what you want is to have a retention time at a certain height for 10 minutes. And basically what retention time means is whenever that fire suppression foam comes out, you want it to stay at a certain level. So say your servers are 6 feet tall, you want a 6-foot retention at 10 minutes. And so you have to know what type of fire suppression you're using. You'll enter that into the software, and then you'll do a blower door test just like you're doing here, except you want it to be tight at 6 feet and below, but you want it to be leaky at the top. So the way that works is whenever that clean agent fire suppression is ejected, it creates a really quick high pressure, high enough to where it'll blow ceiling tiles out, it'll blow drywall out. And so you want to be able to have leakage at the top to where that pressure can escape. So in a lot of cases, they'll put in these vents that whenever the fire suppression is released, those vents will immediately open to allow that pressure to escape. So you'll run a blower door test similar to what you're doing now. There's an extra test in some cases where if you have a drop ceiling, you'll do a BCLA test. So you'll see, neutralize the pressure between that ceiling above and the room itself. So there's a little more in depth to go into, and we have some online fire trainings that you can take. There's 3 different courses that you can go through to get our manufacturer certification in that. So if that's something you're interested in, I definitely recommend going to check that out.
Great. Thank you, Sam. Looks like the last question that I see here. Don't see any new ones coming in, so I think we may be done with questions for the day.
Okay, cool. Well, wrapped up a little early then. Well, I hope this was valuable to you. And if you guys have any kind of feedback, usually the design for this is to have a couple of different cameras, but for whatever reason, Zoom doesn't like that. So I'm going to have to figure something else out. That way I don't have to pick up one camera and move it around. I can just flip and show you different things. But anything else you would like to see or any kind of feedback or maybe something to make things roll a little smoother, I am all ears. So I appreciate you guys giving me this opportunity to come in and talk to you guys about this today. And I hope it was beneficial to you.
Great. Thank you. Yeah, we really appreciate you putting it together. And on the note about feedback, I did just put a link to a survey in the chat. If folks can just take a few moments to fill that out, be helpful for us for moving forward and figuring out what to do for future trainings.
Cool.
But thank you everyone for being here. And Sam, thank you so much.
Absolutely. Thank you guys, and have a safe and happy holiday season.